Hi everyone. In this lecture, we are going to talk a little bit more about the copy constructor. So in the last lecture, we saw that this syntax gives us an error. We will avoid it because we cannot copy the name of the array, or we cannot uh, assign something to the array name, because array name is a read-only constant. So name here points to a memory. So we have a array name and we have a array whose name is x dot name. So what we actually want to do is we want to copy the contents of this array to this array. What we will do, let's say if this is ABC, then we will put ABC here. Okay, so we'll say let us copy using string copy, and we will copy x dot name, that is the destination, and this is the source. X dot name is the source. If I do this and run my code, it is going to work perfectly fine. And if I show you the output now, we can see that even the name value is getting copied in the three objects that we have created. And maybe you may say, okay, handycam dot set MRP equals to, let's say, 1000, then this MRP will also get updated. So if I run this, so you can see this has a different MRP. Now let's talk a little bit more about so now we want to actually talk about a concept, that is shallow copy and deep copy. So copy constructor is going to create a copy of a given object, but we need to define our copy constructor if an object has pointers to dynamically allocated objects. So this is the concept that I am going to discuss now. What is going to happen? So let me create a copy of this file and we will write a different code now. So what we are going to do, we are going to, instead of keeping a static array, we are actually going to keep a pointer to a dynamic array. Okay, so this array will lie in a heap memory. So what I'm going to do, instead of writing this name, I'm going to say let us say this is something. So instead of saying this is name, we can say it is char star name, and here we are getting a pointer, and we can say, okay, if we are getting a pointer to an array, first we will allocate this array. So I can say name equals to new char, and how much space we will need, that will be strlen of n plus 1, and then we are going to copy everything inside the name array. Okay, so first we are allocating the memory depending upon how big the name is. Earlier everything was of length 50. Now if the name is, let's say, handycam, or if it is GoPro, so we are going to allocate a space of length 6, 5 for these, one for null character. So it's a dynamic array. So name is going to point to a dynamic array that is going to store GoPro, and this lies on the heap. And this is one change that we need to make inside the constructor. And here also maybe what is going to happen, let us just comment out the copy constructor as of now, because we want to learn about a concept. Okay, so if I now say I want to change this version to GoPro 8, so I have, let's say, another camera. So let me just comment this out as well. So I want to say I have a product, that is this camera 1. I have a camera old also. So there is a old camera which is the same model of camera 1, and now I'm going to say let me update a particular name of the let me try to update the name of the old camera. Maybe I want to make it GoPro 8. So what I will do, let me try to expose a particular variable. Maybe I can give a function void set name of the camera, and here I give char star name, and I simply do strcpy, I say name, this arrow name, and name. So I've created actually a setter for the name. Okay, so this is a setter for the name. So now what is going to happen if I say let's say old camera dot set name, and I say okay, it's GoPro 8. Let's say this is the name for the camera. So right now yeah, let's say this is the name for the camera. Okay, so let me see if we can do something here. I can say old camera dot show details, and I can say camera dot show details. So you can see we have used copy constructor to create the old camera and parameterize constructor for the first one. This is a warning that we can ignore. And if I run the code now, so now what you can see is the names of both the cameras have been changed. Ideally this should not happen. Okay, now what is actually happening at a code level is, if this is GoPro 8, this is GoPro 8. So if you are thinking that I have done something wrong, let us also update the price of the old camera. Let's say that one was cheap, maybe set selling price, and maybe it is just 1000, let's say. And let's build the code. And if I show you, you can see the price of the old camera has been updated as 1000, whereas the price of the new camera is still 26,000. And the name of the old camera is GoPro 8, and this should have been GoPro 9, GoPro Hero 9. Okay, so this was the name. Now what actually happened? What happened behind the scenes? This is very important to understand. So let us see what is actually happening behind this entire story. So what it did, it called the default copy constructor. So we had a camera object in the memory. This was camera, and we created a old camera object using the camera object. So this is now old camera. Okay, old camera. So this was GoPro 9 and this was GoPro 8. So how is this name stored? Okay, so this name is actually a pointer that points to some memory. Let's say this address is 100, and here we are storing the string GoPro 8 or GoPro 9, and this 100 is actually stored here. Okay, and similarly we have a price variable. Let's say it is 28k and something, and here also we have a name, we have a price, and when this object was created, everything was copied as it is, including the name. So name property had a value 100, so that 100 was copied here. Price was 28k, that 28k was copied here. Then we called the method set name for this one, and we said okay, let us change the name of this to GoPro 8. So what had happened, it was pointing to the same memory because the actual array was not copied, but instead what happened instead, it actually copied the address. Okay, so it actually copied the value that was there in the pointer. So this happened because the copy was not a deep copy, it was a shallow copy. So this is known as a shallow copy. When we are not pointing the copying the actual memory, we are just copying the address. So then I did okay, let us update the price to 1k, and let us update to the name to GoPro 8. Then it actually changed the name of this camera to GoPro 8, and that change would reflect here as well and here as well. Okay, so that is why you can see the price would remain same, but the memory that was lying outside somewhere in the heap, that was shared by the two objects, and this is causing problems. Okay, so how we can handle this? So the answer to this is we will actually create a deep copy, and in order to create a deep copy, what we need our own copy constructor to do the work. Okay, so what this constructor was doing, it was actually doing something like this. It was doing name equal to x dot name. So this work is done by the okay, so this code, you can see it is building fine, and this work is done by the shallow copy. So this is how exactly the shallow copy is created. It just blindly copies all the values without looking at what memory should be copied and what should not be. So if I run this code, you will see the same output. The name is changing, but the price is not changing because price is in a different bucket, but the name is in the common bucket. So how do we handle this? So the idea here is you first point this name to some new memory. So you should create a new memory. So new char of strlen of x.name plus 1. So you first create a new array. That means instead of using this arrow, we say okay, name, while copying we will first create a new array whose length is same as this one. Okay, then in this new array, maybe this address is 824. So this address is 824. In this address we will copy what is there in the original array. So we will say okay, let us copy strcpy, let us copy in name whatever is there in x.name. Let's do the copy. Okay, and now if I run the code, you will see that the new name is GoPro 8 for the old camera and the original one still remains GoPro Hero 9. This is the concept of a deep copy. Okay, so we are now having two arrays. This is GoPro 8 and this one was original GoPro Hero 9, so it remains as it is. Okay, so this is what we have done in case of using a deep copy constructor. So I hope this concept is clear, and this is what I wanted to teach you. So we need to define our own copy constructor if the object has pointers to dynamically allocate object, and that means a deep copy of the object is needed. So I hope you really understood this concept well now, and that's all for this lecture. So thank you, and I will see you in the next video.